Okay guys, this is Monday's notes, February 4th. We're going to start graphing inverse trig functions. So here's a reminder of what y equals sine x looks like. And remember last week we talked about restricting the domain. So we took a section of this graph that's 1 to 1. So we took the part from negative pi over 2 to pi over 2. So that's what we're looking at right there. So these are your critical points, pi over 2, 1. Negative pi over 2, negative 1. And when we flip those, we get 1 pi over 2 and negative 1 negative pi over 2. Notice this part right here is down like a frown, so this part right here is up like a cup because this is a reflection over that line y equals x. So this is the parent function for the inverse sine function, y equals arc sine x. The domain for this graph is negative 1 to 1. The range is negative pi over 2 to pi over 2. And then this right here is just saying that we can apply all of the transformations to an inverse sine or an inverse trig function just like we have every other function this year. So here's an example. Y equals absolute value arc sine x over 2 minus pi over 2. We have three transformations here. We have a horizontal stretch by 2. That's because my b is 1/2. Now in the past, or for sine x, we use the formula 2 pi over b. Now if you want, you can just use 2 over b. So 2 over 1/2 is 4. What this is right here, this is the total width. The total width of our new graph. Now notice the parent function up here, the total width is 2. So now our total width will be 4. Okay. We have a couple more transformations here. We've got down pi over 2. And then the last one there is the absolute value on the outside, which says that we have no negative y values. So I'll show you what this will look like. I'm going to sketch the parent first. Looks something like that. Whoops. Okay. Now we're going to stretch that by 2. So if my total width is 4, then this needs to come out 2 this way and 2 this way. So this point's coming all the way to 2. And this point right here is coming all the way to negative 2. And then, so that makes my total width 4. I'm going to move everything down pi over 2. So this point comes to right here. This point comes to negative pi over 2. And then this point comes down to negative pi. So now my graph looks like this. And then the last one, no negative y values, so that needs to be flipped up. So instead of negative 2 negative pi, it'll now be negative 2 positive pi. That's what the absolute value does. This negative pi over 2 becomes positive pi over 2, and the graph looks something like this. And you're done. Okay, the next one, the cosine graph. Remember we took the section from 0 to pi, this bolded section right here. That's the part that's 1 to 1. So we flip all these points and we end up with something like this. Instead of 0, 1, it becomes 1, 0. Instead of pi over 2, 0, it becomes 0 pi over 2 and negative 1 pi. So let's apply some transformations to this graph. We've got a vertical stretch by 3. Because my b is greater than 1, this becomes a horizontal shrink by 2. And now this time we've got absolute value on the inside, so that's the one that we call erase and replace. And I will remind you what that means. It's been a while since we've done anything with absolute values. That's why I threw them on here for you. So let's take our parent function. I'm going to change this up a little bit. Give myself a little room up top since I have that vertical stretch. There we go. So let's say this is pi. And there's 1, -1, and there's pi over 2. So my parent function looks like this. Okay, so we're going to stretch that by 3, so instead of going to pi, it's going to go all the way up here to 3 pi. This pi over 2 turns into 3 pi over 2. So now my graph looks like this. My horizontal shrink by 2, so instead of going out to 1, it now goes to 1/2 on each side. So my total width was 2, now my total width is 1. If I take, instead of 2 pi over b, we use 2 over b. So 2 over 2 is a 1, so total width of 1. So now it still goes through 3 pi over 2. I'll make this a little darker so you can see what's going on here. There you go. Now, the very last one, the absolute value on the inside is your erase and replace. What that means is we're going to erase everything on the left side, and we're just going to replace it with a mirror image of the right side. And you're done. Now the last one. Remember that tangent has vertical asymptotes at pi over 2 and negative pi over 2. It's the snake that runs down through 0, 0. I gave you these other key points, pi over 4, 1, -1, negative pi over 4. So when we reflect it over y equals x, now those vertical asymptotes become horizontal asymptotes. We have key points at 0, 0, 1 pi over 4, and -1, negative pi over 4. So let's work an example here. Absolute value 6, inverse tangent x minus 1. So we're looking at a vertical stretch by 6. The next one is the right one, and then the last one will be no negative y values, because the absolute value is on the outside. Alright. So if this one's at negative pi over 2, the two horizontal asymptotes are at negative pi over 2 and pi over 2. If I stretch those by 6, they're going to go all the way up to 3 pi this way. So we'll say this is pi. This is a negative pi. So this graph right here looks like this. It's been vertically stretched by 6. Now it moves right 1, so that point comes right here. And then the last one, no negative y values, so everything down here just flips up. Now, this point, it was at 3 pi over 2. So now it's at 3 pi over 2. So it's going to go down through that, but this part that was down here flips up. So this was at 0, negative 3 pi over 2, so now it's up here at positive 3 pi over 2. Okay, the reason I knew that that was 3 pi over 2 is because the vertical stretch by 6, it was pi over 4, so when you take pi over 4 and you stretch that by 6, you get 3 pi over 2. Also because it's halfway between 0 and 3 pi. Halfway between 0 and 3 pi. So there's your final graph for that one. Alright, so there's your graphs with some transformations for inverse trig functions. Enjoy.